Okay, so I have a question from a student about calculating average atomic mass. I don't have a screenshot for this. It's in chapter 2. I think it's section, let me get a different color here. I think it's section, it's TRO 2.7, I think. So the question is this: silver has an atomic mass of such and such, okay? One isotope, silver 107, is blank. What is the mass of the other isotope? Okay, so let me remind you before I begin the solution that the formula for atomic mass misspelled that. I'm going to put another little hump there. Atomic mass is equal, it's a weighted average, right? So it's the sum times the weight of each isotope. I'm going to say I over N, all right? Divided by 1. And the weights are all 1, okay? So, N, all right? Now that we define this in the, I don't know what page this is on, but we define this by saying, with two isotopes, it's going to be simply this. It's going to be the percent of the one times the weight of the one plus the percent of the other times the weight of the other, right? Or the mass of the other. Now look, it's a weighted average. What this means is these percents are going to all add up to 100%. So we don't have to divide by 1 because it's just 1. All right, so having said that, it's important. Let me go to a different color now and ignore the black. This, I would say this black is really a key to your success because it's going to be really, really simple to laying out. Now that we've laid it out, now that we understand the formula, let's lay this out. We know the average atomic mass, which is 107.868, is equal to the percent of the first, which is 0.4816. Okay, can you see why I got that? Times the weight of the first, which is 108.905, plus the percent of the other. What is the percent of the other? Well, it's 100 minus 48.16. Okay, so this goes to 84 and 9.1, so it looks like it's 51.84%. 0.5184% times the mass of the other. This is the given isotope. This is the one in question. Okay? So now that we've got that, can you see that we're just solving for box over here? So this is going to be 107.868 minus 0.4816 times 108.905, because I subtracted that from both sides. Divide by 0.5, just a second here. Divide by, just a second, sorry, 0.5184, and we're going to be left with box. All right, so let's calculate this. 107.868 minus, wait, this is 0.4816 times 108.905 equals. This, I'm going to do another color yet. Can I? Do you mind if I do that? Let's do yellow. Let's say these two together, that times this is 52.448648. Right? This is 107.868. So the numerator is going to be 107 minus 52. Okay. Plus 107.868. Equals, so this is going to be 55.419,352 divided by 0.5184. 0.5184. And this is going to give us, divided by 0.5184, is going to give us 106.904,614. Now, if this is free response, which it looks like it might be, I'll go back and look at it in a second. We've got to figure out how many sig figs we have here. So this is a multiplication problem. This answer, this number is going to have, you see, this is a multiplication problem. That's going to have 4 sig figs there. This says 6 sig figs. Okay, and it's divided by 4 sig figs. So it looks like we're going to be, you agree this has 4 sig figs? It's 4 sig figs, 4 sig figs, okay. So this is going to be 4 sig figs. So this is going to go to 106.9 AMU, okay? And again, the whole premise is the average. How are we going to get a weighted average? If you can understand the weighted average here for this kind of problem, you're going to be golden. Okay, I hope that's helpful.